The great beyond and high definition. With the James Webb telescope, we can do just that. This telescope is an infrared observatory orbiting the sun about 1 million miles from Earth, and it's to find the first galaxies that formed in the early universe and to see stars forming planetary systems. The James Webb telescope represents a massive leap forward in our ability to study our universe. The benefits of the James Webb telescope and how we can study more of the universe because of it. So what is the James Webb telescope? Well, it is a space-based observatory optimized for infrared wavelengths, which will complement and extend the discoveries of the Hubble Space Telescope. It will have longer wavelength coverage and greatly improve sensitivity. The longer wavelengths enable Webb to look further back in time and to find the first galaxies that formed in the early universe and to peer inside dust clouds where stars and planetary systems are forming today. So what do we expect to find? It is designed to look deeper into space and to see the earliest stars and galaxies that formed in the universe and to look deep into nearby dust clouds to study the formation of stars and planets. To do this, the Webb will have a much larger primary mirror than what the Hubble does, giving it more light gathering power. It will also have infrared instruments with longer wavelength coverage and greatly improved sensitivity than the Hubble. Finally, the Webb will operate much farther from Earth, maintaining its extremely cold operating temperature, stable pointing, and higher observing efficiencies than with the Earth. So what are the benefits overall? The increase in the aperture will yield finer detail as well as the ability to collect more light, allowing it to capture fainter and fainter objects. It is primarily designed for IR and near IR imaging, allowing it to see past many of the dust clouds in our galaxy, particularly those in the galactic center, because it is going to be parked in an orbit far from Earth. There will be far less IR background that will interfere with its imaging, allowing it to produce better images for us. Seeing the various attributes of the James Webb telescope, we will now discuss why it is better than the Hubble Space Telescope. So what does make it better? Well, the longer wavelengths to go beyond what the Hubble has already done. More distant objects are more highly redshifted, and their light is pushed from UV and optical into the near infrared. Observations of these distant objects, like the first galaxies formed in the universe, for example, requires an infrared telescope. Webb will primarily look at the universe in the infrared, while the Hubble studies it primarily at the optical and the ultraviolet wavelengths, though it has some infrared capabilities. Webb also has a much bigger mirror than the Hubble, and the larger light collecting area means that the Webb can peer further back into time than what the Hubble can do. Hubble is a very close orbit around the Earth, while the Webb is about 1.5 million kilometers away. The James Webb Telescope represents a massive leap forward in our ability to study the universe. As it has been shown, the James Webb Telescope will allow us to go beyond more than what we have already been able to explore and see with the Hubble Space Telescope. Though the Hubble may have its limitations, the next observatories can make us far beyond what the Hubble's limitations are. While the Hubble might discover some nearby first galaxies, James Webb might discover them as they're in the process of shaping or forming the real first moments.